Okay, so this is the one that I said was not mandatory, but maybe you want to do it just for extra practice. And the noise you hear is my apartment being ripped to shreds in repairs. So forgive me, apologies for that. All right, nevertheless, define rational number. Rational. Rational is a number that can be expressed as a ratio of two integers. I guess if I'm speaking very simple terms, I can write it as a fraction. It's a rational number. And irrational, a number that can't be expressed, cannot, as a ratio of two integers. Sorry, I forgot the two here. Two integers. Okay, so let me give you some examples. So rational numbers. Remember, in the world of the rationals, right, we had the counting. Right, and the counting, I'll write it over here on this side because I don't make the big. It's 1, 2, 3. No fractions, no partials, no anything. 2, 3, no decimals. And then after that, they added the 0. So the family got bigger. And now we don't count and count. We don't call it count anymore. We call them the whole numbers. They grew bigger. And now we have the negatives, -3, -4, -5, etc. So it was whatever was before the whole numbers and their opposites. Again, no fractions or decimals. So again, we have the integers. And then finally, everything else that we don't write it. The decimals, the terminating decimals, the repeating decimals, right? That's it. And then in the irrational side are any numbers that I can't write as a ratio of two integers. So, for example, square root of 2 pi. If you took the square root of 2, right, it would give you a decimal that goes on forever and ever and ever and does not repeat. And I can't change it to a fraction because I need that place value of the last digit. And because I don't know the place value of the last digit, I just can't change it into a fraction. So your calculator, if you actually were to put that, would be 1.41213562 ... Remember, when I change a decimal to a fraction, for example, 0.5, I know the 5 in the tenth place, so I put a 10 over here, and I change that to 5 over 10. 1.347 as a fraction. Oh, look at the 7. It's in the place value of the thousands. And it'd be 1,347 over 1,000. So I can change that to a fraction. And also repeating 0.77777777. Okay, and we worked out in class, right? Multiply both sides by 10 and then subtract. You end up getting 7 over 9. So I can change a repeating decimal into a fraction. But I can't change a non-repeating, non-terminating fraction decimal into a fraction. So that's why it makes it irrational. So two sides. Remember, also, so it's, for example, number 5 is part of the counting family. It's part of the whole family. It's part of the integers, and it's also a rational. Okay, the negative number -8. -8 is not a counting number. It doesn't belong with the whole numbers, but it belongs with the integers and it belongs with the rationals. Okay, so just a little be careful over there. Evaluate. So it says and round to nearest 10. So if you take the square root of 61 in your calculator, you get, and it says round to nearest 10, but I'm not going to do that. So I'm just going to go 7.8102496676 ... What kind of decimal is that? A decimal that goes forever and ever and does not repeat, so that makes it irrational. Square root of 4 over 64, if you took the square root in your calculator, we're looking for two numbers, in this case two fractions. So multiply, give you 4 over 64, and that's 2 over 32. sorry, 2 over 8. 2 over 8 times 2 over 8 is 4 over 64, so the square root of 4 over 64 is 2 over 8, which makes this rational. Cube root. So enter the cube root. What number times itself 3 times equals 1,728, and that would be 12, because 12 times 12 times 12 is that. So the cube root of that, the positive, right? Remember, the positive cube root of the cube root of a positive number is a positive, so this is 12. Negative 256. Well, we're not looking for a number that multiplied by itself gives you negative 256, but it's just negating what we're about to do. Find the square root of 256. And the square root of 256 is 16. So 16 times 16 is positive 16, right? 16 times 16 is 256. So the square root of 256 is 16, but we're negating that. So it's actually, the answer is negative 16. Let's add these two. Square root of 36 is 6. Square root of 1 is 1. And 6 plus 1 is just 7. Square root of 81. Oh, sorry. That's rational. That's rational. That's rational. Square root of 81 is 9. Let me just write it over here. 9. We're subtracting square root of 15. So put in a calculator. Square root of 15 is this ugly number. And I'll write it. 3.872983346 ... continues forever and ever. Square root of 15 is not a perfect square. Remember your perfect squares. 1, 4, 9, 16, 25, 36, right? All these are perfect squares, meaning if I take the square root of every single number in this list, square root of 36 is 6, square root of 25 is 5, square root of 16 is 4, etc., right? So, square root of 15 is not a perfect square, which means it's part of the irrational family, because when we try to approximate, we're going to get a decimal that goes on forever and ever, never repeats. So if you subtract, guess what ends up happening? Well, let me add the zeros over here, placeholder, right? Remember how you subtracted in second grade? Do the same thing. When you subtract, you're going to keep subtracting forever, because the square root of 15 doesn't end, so you'll still be subtracting the 0 minus whatever, 0 minus whatever. Obviously, you're going to have to do some borrowing. But whatever answer we get, right, it's going to be a decimal that goes on forever and ever and doesn't repeat. So this rational number minus this irrational number gives me an irrational answer. Which subsets of real numbers does the number negative 8 belong? Well, negative 8 is a rational number, yes, for sure, but it belongs to other families as well. Rational number, negative 8 is part of natural numbers? No. Whole numbers? No. Integers, yes. And rational, yes. So, it's not A, it's not B, because A is missing something. C, it's part of rational numbers? Yes. It's part of the integer family? Yes. And my answer is C. And D says it's irrational, but we know it's not irrational, so we don't even have to bother looking at it. Square root of 50. I'll take the square root of 50. Again, go in your calculator. We know it's not a perfect square, right? Right, so the perfect square is 1, 4, 9, 16, 25, 36, 49 is the next one. Square root of 49 is 7, so that's a perfect square. And the next one would be 64. So square root of 50 is in between 49 and 64, but it's not a perfect square, which means this is going to be a decimal that goes on forever and ever and doesn't repeat. 7.0710678812 ... makes it irrational. So first of all, square root of 50 is not rational, so that's a way, not a natural number, so that goes away. It's not a natural number, it goes away. It's irrational, right? I can't write this as a ratio of two integers. Okay. Put the following in order from least to greatest. Okay, so if you're going to do that, make sure you change everything to decimals, because then you can compare much easier. So, square root of 9, square root of 9 over 2. You're going to have to put that in your calculator. And that, the first number here, I'll write it on top, 2.1213, and I'm going to stop there, because it goes on forever and ever. 0.5 is already a decimal. 1 over 6 as a decimal is 0.166666666. So I'll just write a few of them. Dot, dot, dot. 1.6 is already a decimal, and square root of 4 is 2. So let's put this in order from least to greatest. You don't have to do a number line, but hey, it comes in handy. So our smallest number is 0, then we're going to go 1, we're going to go 2, and we're going to go 3. So let's do it in our square root of 9, which is 2.12, somewhere over here. So I'm going to put square root of 9 over 2, or 2.12. 0.5 is somewhere over here, right in the middle between 0 and 1. 1.6 is 0.16666, which is right over here. Sorry, 1.6, I don't know, I have 1.6. No, I'm doing 1 over 6, so that's 1 over 6 is 0.16, so I'm going to write as 1 over 6. So this is done, that's done, that's done. 1.6 is up around here, between 1 and 2, closer to 2. And then square root of 4 is 2, and I'm going to write it right here. So is there a multiple choice that starts with 1 over 6? Oh, there it is, right here. The next one is 0.5, checks. The next one is 1.6, check. The next one is square root of 4, check. And the next one is square root of 9 over 2, check. So look at the order here. That's the same exact order that we have here. So the answer is A. Which symbol makes the sentence true? Well, so you have two things here. 9 of them are written in a way that it's easy to understand. So I'm going to take my calculator and find what the cube root of 27 is. And the cube root of 27 is just 3. If you press pi in the calculator and then you press this button over here, it's going to give you a numerical value. Press enter, and you're going to go, so if you press pi, press that button I just said, and enter, it's going to show you that pi is 3.145926, blah, blah, blah. So, is 3 greater than that number, or is it smaller than that number? Obviously, it's smaller, right? So, cube root of 27 is smaller than pi, less than pi, and that's the answer. But notice that what I had to do, change them to standard notations, a decimal or whole number, and then compare. Much easier to do it, right? No need to guess. 1 second. Wait. Ah, sí, claro. Ya está aquí. Un momentito. No. Frío, no tengo frío. Normal, ¿a tiempo? ¿Hay soda también, coca? Ok, gracias. Alright, so now we have to do the second page. If you turn the page over. And it says a garden has an area of 225 feet squared. Well, hopefully you recognize the number 225 and you know it's a perfect square. So the garden, well, a square garden, all right? So that's your key. So it's a square. And they're asking, hey, what does this side measure and what does this side measure? But they give you that this is 225 feet squared. Right, so if it's a square, hint, hint, you know that all sides measure the same thing. So this number and this number is exactly the same. And because we know 225 is a perfect square, and therefore we know there is a nice whole number waiting for us. And in this case, it's 15, because 15 times 15 is 225. So if the square garden has an area of 225, what are one of the sides? It's 15. Given A, square root of 20, and B, square root of 25, we're going to add these two, okay? And then you're going to tell me if it's rational or irrational. Put a little star next to this question, please. Hint. So let's change square root of 25. We already know what that is, which is 15 from the previous question. And now square root of 20, well, we know it's not a perfect square, so it's actually, and I'm going to write this down, 4.47213555 dot dot dot. Goes on and on and on. We know it's an irrational number. So we're adding an irrational number plus a rational, and you're to tell me what kind of answer I get. Do I get a rational number? An irrational? Let's do it. So here's 15. We're going to add a decimal to it, so let me add a decimal here and some placeholders. And at the bottom, let me write 4.4721355955, etc. Dot dot dot. Let's add these. Go through the process. If you add, well, you know it's going to be, well, I don't know what this number is, so I'm going to take that out. So 0 plus 5 is 5. Again, sorry, there's 0, 0, 0, 0, 0, and dot dot dot. So there's numbers here, right? That's a 5, that's a 9, that's a 5, that's a 3, that's a 1, that's a 2, that's a 7, that's a 4, that's a 19. So it's 19.471355955. Right, we stopped here because the calculator couldn't give me any more decimals on the square root of 20. But we know you would have kept adding this, adding this, adding this, adding this, and continue adding forever and ever because it never stops. So the end result, you get a number. The end result, you get a number that is a decimal that goes on forever and ever. So, and it does not repeat. So what kind of answer do I get? I get an irrational number. So there you go. Use this as a base for your explanation. Write the following as a fraction in simplest form. 0.44 dot. What the heck? So that, ladies and gentlemen, is a repeating decimal, right? There's a dot, dot, dot. I just couldn't see it. So it's 0.4. We learned in class how to change that to a fraction. So x equals 0.4. Okay. You want the trick? It's a multiple choice question. Go in your calculator, put 44 divided by 1,000. Enter. See if you get 0.44444 forever and ever. No. Put 44 divided by 100 and see if you get 0.44 forever and ever. You don't. You get 0.44. Put 4 divided by 10. You get 0.4. And then put 4 divided by 9. 0.44444444. You need to know that it's repeating. Right? So that's one way of doing it, the way we did it in class. We're going to set up an equation. Set x equals 0.444444, repeating. And then how many numbers are repeating? One number is repeating, the 4. So we multiply both sides by 10. So 10 times x, 10x. And in your calculator, multiply this, dot, 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 times 10. See what happens. If you multiply it by 10, it gets bigger by a factor of 10, which just means simply that the shortcut would be move the decimal one over. So your calculator should be showing this. Dot, dot, dot. And that's what we're going to put on top here. 4.44444 forever and ever. If you subtract the top equation with the bottom equation, 10x minus x is 9x. And then if you start subtracting, it's going to be 4 minus 4, 4 minus 4, so 0, 0, 0, 0. So all this goes away. The repeating part goes away. And 4 minus 0 is 4. What do we do next? Divide by 9, divide by 9. X equals 4 over 9. That's how you get that this, a repeating 0.4, right? This guy right here, changes to 4 over 9 as a fraction. So correct answer, D. Solve the equation. All right, x squared minus 19 equals 30. What do we do first? Well, we want to isolate the x squared, right? So plus 19 on this side, plus 19. These two go away. X squared equals 49. So now, at this moment, I want you to stop and think. There's a number or numbers that I can take to the second power and equal 49. Find them. Well, I need my equation to look like that. So the first thing I'm going to do is take the square root of this side, and take the square root of this side. There's a little 2 here that's hidden. That allows me to simplify those two, right? To simplify to just x, and then on this side takes the square root of 49. And in this case, because it's an equation, your answer is not 7, it's plus or minus 7. Let's do a check. Let's try the 7. So if I take this equation, plug in a 7, so I'm going to get 7 squared minus 19 equals 30. I get 49 minus 19 equals 30. And you'll notice that it works. What if I try negative 7? Well, negative 7 to the second power minus 19 equals 30. Negative 7 to the second power is 49. Negative 7 times negative 7 is 49. Minus 19 equals 30. And you'll notice that both numbers are solutions to this equation right here. Positive 7 and minus 7. Guys, this whole thing is what gets you full points. Okay? And we have another one. Okay, 2. It's the same thing. 2b squared plus 25 equals 225. That's the first thing we do. Minus 25 on this side, minus 25 on that side. Right, that goes away. I'm left with 2b squared equals, what is that, 200. What's the next step? Remember, there's a multiplication sign here. I need to get rid of that 2. Remember, we need to get that to look like this. So slowly, let's start getting rid of coefficients, constants, exponents. So divide by 2, divide by 2. That simplifies to 1. I'm left with b squared. 200 divided by 2 is 100. I'm going to take the square root of this side. Let's take square root of the side. Remember, this 2 and this 2 cancels. Left leaves me with b. What's the square root of 100? Not 10, but plus or minus 10, because it's an equation that we're trying to solve. Do a check. It's 2 times 10 to the second power plus 25 equals to 25. Your second check would be 2 times negative 10 to the second power plus 25 equals to 25. So you're checking the equation with 10 and negative 10. 10 to the second power is 100, so it's 2 times 100 plus 25 equals to 25. 2 times 100 is 200 plus 25 equals to 25. And you can tell that left side equals right side. Same thing repeats here because there's a negative times a negative, which is a positive, and 10 times 10 is 100. So you have exactly the same thing on this side. 200 25 equals to 25. 225 equals to 25. And then finally, last 3. This you'll have 2 questions at least on this. So please go over the exponent rule. Let's do the first one. 45x to the third, y to the negative fourth, 9x to the 8, y to the negative 8. So let's do it in parts. There should be 3 parts here. Coefficients, the x's, and then the y's. So look at that. It's 45 over 9, which is the same thing as 45 divided by 9. So let me write the fraction, take care of that. 45 divided by 9. It's not 5 in the denominator, because if you write in the denominator, that's the same thing as writing 1/5. That's not the answer. 45 divided by 9 is just a whole number 5, which goes on top. x3 and x8, remember, what do we have? Where do we have more x's, top or bottom? We have more at the bottom. How many more? 5 more. So there we go. Right, remember, 1, 2, 3x on top. 1, 2, 3, 4, 5, 6, 7, 8. Simplify, simplify, simplifies. Where do I have leftovers? How many? At the bottom, denominator. How many? 5 of them, right? Because it's x times x times x times x times x. Done. Y negative 4, y negative 5. I'm going to do a few things before I... y negative 4 is a negative exponent, so I'm going to throw it to the denominator. It becomes positive. Y to the negative 5th is a negative exponent, so it's going to go up and becomes positive. So I need one extra step. The 5 is done, the x to the 5th is done, and then you look at the y's. There is 1, 2, 3, 4, 5, and 1, 2, 3, 4. That goes away. Simplifies, simplifies, simplifies. Where do I have left over? On top, how many? 1. This should be your final answer. Next one. It's an power to power, right? So 7 h to the 8th power. All that raised to the 2nd power. So first thing you should do is put a little 1 here. And then now you get to multiply the exponent that's outside with every exponent inside. So it's a 7 and an h. Let's do the exponents. 2 times 1 is 2. And the h has an exponent of 8 multiplied by 2 is 16. This could be your final answer, but because 7 to the 2nd power is such a small number, we can actually change 7 to the 2nd power and write 49. H to the 16. That is your final answer. Last one. 4x minus 3 equals 2x plus 9. Go through the process. When we solve the equations, first thing you have to do is look for distributive property. Is there? No. Move along. Second thing, combine like terms. Can I combine 4x minus 3? No. Can I combine 2x minus 9? No. So that's done. Variables on both sides. Is there a variable on both sides? Yes. One side has 4x, the other side has 2x. So get rid of one of them. We said in class, taking out the variable with a smaller coefficient is better, I guess, preference, because it avoids you dealing with negatives. So how do I get rid of 2x? Minus 2x. Minus 2x on this side as well. That goes away. 4x minus 2x is 2x. Minus 3 equals 9. Now it's super easy. Plus 3 over here. Plus 3 over here. 3 goes away. You get 2x equals 12. Remember, that's multiplication, so the inverse operation is division. Divide by 2. Divide by 2. X equals 6. Don't forget to check. 4 times 6 minus 3. 2 times 6 plus 9. They should equal to each other. 4 times 6 is 24. Minus 3 gives me 21 on the left. On the right, 2 times 6 is 12. And 12 plus 9 is 21. There you go. Can't get any easier than that.